Okay, so the second unit of trig is going to start with cofunction identities. Now really what we're going to do is we're looking at identities this unit. So let's think back to last year. We had the reciprocal identities, which are the three that we looked at last unit. So secant is 1 over cos, cosecant is 1 over sine, and cotangent is 1 over tan. We also have the quotient identities, which really it's just tan is sine over cos or cotangent cos over sine. Now we get the cotangent one just from our reciprocal identity. It's nice to remember that because it can help you with identities. Then we have the Pythagorean identities, which is sine squared plus cos squared equals 1. And then you can rearrange it for both sine and cos, or sine squared and cos squared. Now, cofunction identities are really just special properties of a triangle. They help us relate sine and cos together, or cotangent and tangent, or cosecant and secant. Now, we're just going to look at the sine version of it, and I'm going to use a 3, 4, 5 triangle. You can really use any right angle triangle, but a 3, 4, 5 is a nice way to look at it. The numbers are nice and easy, and it works this way with any of the identities. So first what we need to recognize is that 90 degrees is really pi by 2. So that means the whole inside of a triangle is 180 degrees is equal to pi. So if I looked at angle B, we've only got pi by 2 left. It's really equal to pi by 2 minus angle A. Well, if I look at sine of angle B, you know the sine is opposite over hypotenuse, so 3 over 5. That's going to help us kind of look at what the actual identity is. If we look at cos of angle A, that's also 3 over 5, but that's really pi by 2 minus B. Okay, so we can look at this logic with any of the identities and make them. If you haven't kind of put together what the identities are, they are the following. So the cofunction identities are sine A would be equal to cos of pi by 2 minus A. Tan A is equal to the cotangent of pi by 2 minus A, and secant A is equal to cosecant of pi by 2 minus A. So it's all just the complementary angles. Graphically, you can look at this. I don't really like to look at graphically, so what I've done is I've just put it into Desmos. I'm showing you the negative pi by 2. Really, the sine graph, which is in red here, is exactly the same as the cos graph, which is in blue, but the cos graph has been moved back pi by 2. Typically, we think of starting the cos graph at the maximum and then going down to the minimum and back up. But if you think you've just moved the whole graph back pi by 2, we can think of that identity and understand that it does work. Now, I'm going to show you this first example, and I'm going to do it exactly as the identity states. So rate each of the following in terms of the cofunction identity. So first, we have to recognize that sine theta is equal to cos, and then we've got pi by 2 minus theta. Well, that means that sine of 5 pi over 4 is equal to the cos of 2 pi over 4. I've just made this pi by 2, but relative to 4, so we have a common denominator, minus 5 pi by 4. So that's just negative 3 pi by 4. Now that's not really nice to write, so what we need to recognize is that a lot of the times we have to write our answers in terms of pi, but between 0 and 2 pi. Now we know that our period here is 2 pi, so we can always add 2 pi and get the same answer. So what I'm going to do is add 2 pi to this answer to get an answer within the 0 and 2 pi range. Going to be 8 pi over 4, which is going to give me cos of 5 pi by 4. You need to make sure that you're checking your signs when you're putting these in, but it should work every single time. If I look at this, sine 5 pi by 4 is in the third quadrant. It would be negative, so would cos 5 pi by 4. I want you to try this one on your own. You're going to see a unique property with it, but the answer should work out the exact same way as long as you follow these steps. The last question, it's worded a little bit differently. I've looked in a lot of different textbooks and I do see this question worded like this quite often. What we just need to do is prove what it's showing. I'm going to show you how I would do that and how I would expect to see it. So the first thing we need to do is state what we're given. So we're given this value. Now we need to understand that we've got sine theta equals cos of pi by 2 minus theta. Now really the next two steps are going to give us our final answer. Okay, so we know that this, so again, you wouldn't actually have to show this step kind of in the middle here. I'm just giving you exactly what I'm doing. Pi by 2 minus pi by 4 gives me that. So it's stating that this part right here is true. And then what we need to realize is that this is actually the exact same, but just a negative. We're in the third quadrant. We're moving 5 pi by 4 into the third quadrant. Same related acute angle, so we're just going to have a negative value in front. Okay, so those two steps pretty much give us the answer. I would state this at the start. You don't necessarily need this second line. I would go from here to here, and I would state the whole third or fourth line. And that's it for this note.